Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single math problem from this book. If you're interested in watching any of the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems and we are on page number 286. Please turn to it. Page number 286, the penultimate problem on the page, number 129. Let's see what it has to say. Number 129, tell you what, before we actually solve the problem as it is presented to us, let's do a simpler version of it. Let's do a baby version of it. Once we understand the concept, once we have mastered the situation, then we'll tackle the actual problem that is being asked. Here's the simpler version of it. We are told, this is 129, we are told that we have a region R, which is defined as 2x plus 3y is less than or equal to 6. Let's first locate where this region is in the Cartesian coordinate system. So here is our x-axis, here is our y-axis, and we have to first locate this region here. So first we solve this as an equality, 2x plus 3y equals 6, so that we can get the line. If x is equal to 0, when x is equal to 0, 3y is equal to 6 and therefore y is equal to 2. That's the easiest, simplest, most economical way of plotting a straight line, which is to locate the two intercepts, the x-intercept and the y-intercept. When x is equal to 0, we are along y-axis and y equals 2. 1, 2. Here is the 1 point. Similarly, now the x-intercept. For x-intercept, we said y equal to 0. When y is equal to 0, 3 times 0 is going to be 0. 2x equals 6. If 2x equals 6, x equals 3. 1, 2, 3. Here are the 2 points. And here's the line. Let's give this line a name. We're going to call it line L. So this is our line L. From now on, we will refer to this line as line L. Okay, that's it. And we are told that this region R represents all the points such that when we were to take the x coordinate of the point and the y coordinate of that point, 2 times x plus 3 times y will have to be less than or equal to 6. Since it is less than, this is all the points on this line equal to 6, obviously. 2 times the x coordinate plus 3 times the y coordinate of all the points on this line exactly equal to 6. Anything above it is going to be more than 6. Anything below it is less than 6. So here's our region. The region that we are interested in is this region. Okay, now stay with me in the story and see what happens. So now that we have the region, now I'm going to start our story. So I come up to you, listen very carefully. I come up to you and I tell you that I'm thinking of a point. I'm thinking in my mind a point in this region. Can you tell me what is the question asking? Number 129. Oh, here's I'm not asking you for the x coordinate or y coordinate of the point. Here's what's going on. It says, is the point in the region? So I come up to you and tell you that this is region R. We're going to define this as region R. In my mind, I'm thinking of a point. Okay, listen very carefully. In my mind, I'm thinking of a point. Is that point in that region? To which you will say, what the hell? How the hell do I know? It could be any point that you're thinking of. The point that you're thinking of could be a point over here. Or the point that you're thinking of could be a point over here, in which case it is in the region. Or the point that I'm thinking of could be over here. It's a pretty silly, stupid question. Very moronic questions. Simply for me to simply come up to you and tell you that here's your region R is the point that I'm thinking of in that region. To which your answer would be, as we said before, what the hell? Right? So I'm going to give you hints. I'm going to give you a couple of hints. Okay, As I said already, stay with me in this, stay in the story. It's very important that you stay in the story. So here are your two hints. The hint number one, statement one. Statement one, I'm telling you that the x-coordinate of the point that I'm thinking of, the x-coordinate of the point that I am thinking of is less than or equal to 2. That's your hint. X coordinate of the point that I'm thinking of is less than or equal to less than or equal to 2. What have I told you so far? Are you able to depict this on this graph as to what it is that we've just been told here? What it tells is that the x coordinate of the point that I'm thinking of is less than or equal to 2. Where are all the points such that the x coordinate is less than or equal to 2? Well, those points are going to be right here. This is 2 exactly. So less than or equal to, since it says equal to, we have to draw a solid line, and anything that falls to the left of this red line has the x coordinate which is less than or equal to. Anything, let me say it again, I did not say it properly. Anything that falls to the left of this red line or on the red line, anything that falls to the left of the red line or on the red line has the x coordinate which is less than or equal to any points that you pick here. For example, this point here has the x coordinate of 0, here's another point of x coordinate of -7, here's another point of x coordinate of 1, and so forth. They are all less than or equal to 2. Is there enough hint for you to be able to tell whether or not the point that I'm thinking of is in the region R? The answer of course is no. Answer of course is no, because as long as it falls at the bottom half of the line, you're fine. But what if the point that I'm thinking of falls on the top half? If the point that I'm thinking of falls on the top half, then it is not in the region. But if the point that I'm thinking of in my mind happens to fall on the bottom half of this red line, then it is in the region. But this clearly is not enough information. Statement 1 by itself is not enough. Statement 1 by itself is not sufficient. A, D, B, C, E. A, D, B, C, E. Now that we've established that the first statement by itself is not enough, we know now that the answer cannot be A or D. So here's your second hint. You want one more hint? I'll give you a second hint. Here's your second hint. I'm telling you in the second hint that the y coordinate of the line that I'm thinking of, y coordinate of the point that I'm thinking of is less than or equal to -1. Now listen, I'm about to violate a rule that you must never violate in the exam, and I'm doing it out of sheer laziness. I don't want to erase everything that we have plotted here. So I'm going to leave everything there. It is your job to pretend that the red line is not there. Pretend that the red line is not there, because the red line came from statement 1. When you're looking at statement 2, you must delete everything in your mind. The memory has to be deleted. So pretend the red line is not there. It never existed there. Let's look at the blue line here. Here's your blue line. And it says that the y coordinate of the point that I have in my mind is less than or equal to -1. Here's -1. So as long as the y coordinate is below that, so that represents this blue line right here. This blue line right here. The question is there enough information just by looking at the blue line itself? Can you tell just by the blue line itself if the point that I'm thinking of is in the region R? Answer again is no, because what if the point, as long as the point that I'm thinking of is to the left of this blue point that I just showed you, if it's to the left of it, then it will fall in the region. But what if the point that I'm thinking of happens to be these points? Then they are outside the region. They are outside the region. These points are outside the regions. So second statement by itself is also not enough. The answer cannot be B. Let's put them together. When we put the two statements together, now we are talking. Because when we put them together, the first statement tells us that the x coordinate has to be less than 2, which pulls us to this side. Second statement tells us that the y coordinate has to be less than -1, which pulls us to this side. So now we're looking at this area right here. Now in this region, it doesn't matter which point I'm thinking of, as long as, so what I've told you is that the point that I have in my mind has the x coordinate which is less than 2, has the less than 2, and the point that I'm thinking of has the y coordinate which is less than -1, which means that the point that I'm thinking of, what I told you, is that falls in this right here, then obviously it falls in the region R. So two statements together are enough. Two statements together, turns out, are enough. Answer to this problem was C. But alas, this problem will never appear on the exam. It is too simple a problem. It is way too simple. It is a baby problem. Now let's do the problem that is given to us in the actual exam, shall we? Okay. Give me a break. Here's what we're going to do. First, instead of 2, let's pretend that it is 3. Instead of 2, let's pretend that this is 3. 1, 2, 3, right here. So first statement. So that's it. We are doing the problem. We are doing the problem as it appears in the exam. Watch what happens. So the first statement here is. So what if we are told that the x coordinate of the point that you're thinking of is less than or equal to 3? That will be right here. 1, 2, 3. That's our red line. What if we are also told that the y coordinate that we're thinking of, y coordinate of the point that I'm thinking of is less than or equal to 2. Is it 2? Let me just give me 1 second and I'll tell you. Yes, it is 2. Tell you what, since it is positive 2, I'm going to redraw it. Instead of being lazy, I'm going to redraw it. I just realized that the y coordinate of the point that I'm thinking of, the y coordinate of the point that I am thinking of is less than or equal to 2. So there's your y coordinate less than or equal to 2, x coordinate is less than or equal to 3. Let's redraw it. I'm going to erase everything and redraw the whole thing. But we're not going to spend too much time drawing our region R because it's very simple. We have done it already. So here's our region R. When x is equal to 0, y is going to be 2, 1, 2. And when x and y is equal to 0, this is going to disappear. 2x, that means 2x equals 6. When y is 0, 2x is going to equal 6, which means x is 3. 1, 2, 3. So here's our line L, and here's our region. Okay, here's our first hint. Now, I should no longer speak in terms of first hint and second hint. As I told you before, the problem that we just finished was a baby problem. Here, it is not first hint or second hint. The entire thing is presented as hint number 2. Here's our statement number 2. Watch what happens. This is our statement number 2. Statement number 2 tells us that the x coordinate of the point that we're thinking of is less than or equal to 3. Let's find it. Right here is 3. So it's right here. X less than or equal to 3. Anything that falls to the left of it is fine. It's okay. We also told, now since we no longer presented these two bits of pieces as two separate statements, we're not going to go around putting x's over because we're not done yet. Now the second part of the hint, the second part tells me that the y coordinate is less than or equal to 2. Less than or equal to 2 is right here. Let me put it in a different color. And the region that we find actually, the region that emerges from it, the region that is going to emerge from it is this region right here. How can I highlight it right here? As you can clearly see what the problem is. The problem area is that as long as the problem area is this here, let's call this triangle P, Q, and R. As you can see, the PQ and R only has the orange line. It doesn't have the black line. The triangle PQR does not fall in the region R. So if the point that I'm thinking of, the condition that I'm giving you is that the x coordinate of the point that I'm thinking of is less than 3. Well, if I'm thinking of a point like this one, for example, right here, it has an x coordinate of less than 3, and it has a y coordinate of less than or equal to 2. Let's make it even more interesting. Instead of putting it right on the edge, let's put it right in the center here, right here. That point, that's my point, that's the point I'm thinking of. Is that in the region? Of course it's not in the region R. Any point that falls in the triangle PQR, any point that falls in the triangle PQR is outside the region R. And the other point, all the other points are fine. All the other points are going to be okay. Except the points that fall in the triangle PQR. And therefore, the second statement by itself is not enough. Second statement by itself is not enough. Some of the points, well, I shouldn't say some of the points, almost all the points will fall in the region R, except the points that happen to fall in the PQR. Those are going to be outside the region R. Second statement is not enough. Second statement by itself is not enough, alas. Now ordinarily this is how we would set it up. AD, BCE, AD, BCE. This is the ordinary situation. But this is not an ordinary situation because in an ordinary situation we start with statement number 1. Here we happen to start with statement number 2 because statement number 2 was easier to analyze. Since we started with statement number 2 instead of 1, we have to change our setup. Instead of A, D, B, C, E, A becomes B and B becomes A. Now that we established that the first statement by itself is not enough, or rather, now that we established that the second statement by itself is not enough, we know now that the answer cannot be B. Let me rewrite these things down here. A, D, B, C, E. And A becomes B and B becomes A. Now that we established the second statement by itself is not enough, we know now the answer cannot be B. It will have to be, it cannot be, answer cannot be B or D. It would have to be A, C or E. Let's look at first statement. Let's look at the first statement. I need the room, I need a lot of room. In the first statement they tell us, that the this is the condition it has to follow. 3R plus 2S equals 6. The point that I'm thinking of, any point that I'm thinking of has to meet this condition. Let's see where this falls. Again, ordinarily, technically I should erase all of this thing, but I'm not going to erase it because it's a lot of work. So you have to ignore this thing, just concentrate on the part that we are doing here. And I'm going to do it in an entirely different color. We're going to do it in a green color. So again, when R is equal to 0, 2S is going to equal to 6 and S is going to equal to 3. That's our Y coordinate. 3 is right here. And then similarly 3R plus 2S is equal to 6, and when S is equal to 0, which is our Y coordinate of the point that I'm thinking of, when that is equal to 0, that thing is going to drop out and 3R equals 6, which means R equals 2. So this is our second condition, R equals 2 right here. Watch what happens. Oh boy, this is getting very, very technical. Are you able to see? The problem area? I'm gonna make it darker, very simply, right here. I wish that it did not come out this way, but here's the problem area. I'm gonna make it all black so you can see it. Any point that lies in this region, is our problem area. All the other points are fine. Anything that falls in that tiny small triangle that you see there, any points that falls in any tiny small triangle that's in there does not fall in the region R. All the other points will. And therefore putting the two statements together, it still does not do the job. Answer to this bloody problem is E. Answer is E. Now I'm going to take a couple of points and I'm going to actually convince you that if the points fall in this small tiny triangle that you see there, the black triangle right here, tiny one, any points that falls in that triangle is not in the region R. I'm going to show it to you in a second, okay? As far as the exam is concerned, as far as the problem is concerned, we are done. Let me convince you by giving you a couple of points. How about R and S, we are told. How about 2/3 and 2? 2/3 and 2. First of all, notice that the condition that is given to us, 3R plus 2S equals 6. 3R plus 2S equals 6. R is 2/3, so it's 3 times 2/3. R is 2/3 plus 2 times S is 2. And watch what happens. Watch what happens. 3 is going to cancel out and we get a 2 here. And this is 2 plus 2 times 2 is 4. 4 plus 2 is 6. And as you can see, this particular point falls exactly on the line, the green line right here, somewhere on that green line right there, 2/3. As you can see, 2/3 is going to be somewhere here, there, 2/3 and 2, right here. Right here, about somewhere here is a 2/3 and 2, it falls right somewhere here. 2/3 and 2, right there. That's the point we're looking at. 2/3 and 2, right here is the point in the triangle. Let's see if that now we're going to show that that particular point that falls on the green line, it does fall on the green line because this is the equation from the green line. We're going to show now that it is not actually in the region R. It is not in the region R. Because our region R is this. Our region R is 2x plus 3y. It has to be less than or equal to 2. This is our region R. If the point falls in the region R, anything that you see here, this is our L, this was the original line that is given to us, line L, the black line, and then the two constraint that is given to us. The region R is the common area that you see here, all of this common area. Let me actually show you the region R so you can actually see it. Anything this is technically not the region R, but the region that we are allowed to be in, because region R actually could have gone all the way up to Q. That was the region R there, but then we had the constraint here, so that's the second constraint there. So this is the region we're talking about. That point that we're looking at, 2/3 and 2, is outside it. And we're going to show here that it is outside it. X is equal to 2/3, which means 2/3 plus y is 2, 3 times 2. And you can clearly see that 3 times 2 is 6 already. 3 times 2 is 6 already, plus this amount, whatever this amount, it doesn't matter. The sum of those two is not going to be less than 6. It's not going to be less than or equal to, it falls outside it. Let me show you one more point. Where can we do it? We have no room here, so perhaps we can just squeeze it in here. Let me show you one more point here, R and S again. How about 1 and 3/2. 1 and 3/2. Again, 3R plus 2S has to equal 6. And you'll see that this point also lies on the green line. This is the equation of the green line. 3 times R, which is 1, plus 2 times S, which is 3/2. And 2 is going to cancel out, and this is our 3. 3 plus 3. 3 times 1 is 3. 3 plus 3 is 6. As you can see, it's on the green line. But you will see that it is outside the region R. Where can we show it here? Let's do it out here. Region R. It's going to fall outside the region R, which is 2x plus 3y is less than or equal to 6. Right here, 1 and 2/3. 2 times 1 plus 3 times 2/3. Again, as you can clearly see very quickly, that 3 is going to go 1, and it's not 2/3. You see, I stopped myself because had it been 2/3, it would have worked. Had it been 2/3, it would have worked because 3's would have cancelled out and we would have left with 2. 2 times 1 is 2 and 3's would have cancelled out, and 2 plus 2 is 4. 4 is in fact less than or equal to 6. And this point, the point with the coordinate of 1 and 2/3, does lie in the region R. That's not what we have here. We have 3/2. That's how I caught myself. So we had to put 3/2 here. And what happens? So we end up with 2 plus 3 times 3 is 9. 9 divided by 2, we get 4.5. As you can see, 2 plus 4.5 is not less than or equal to 6. That point also falls outside the region. And the point was 1, right here, 1, right here, 1, and 3/2. This was 1 and 3/2. Right here, that's the point we're looking at. So this tiny triangle that we see, I'm going to magnify this tiny triangle. This tiny triangle that we have there, the first point that we saw was right here, and the second point that we saw was right here. Both of those, anything that falls in this tiny triangle, it's outside the region R. Everything else is okay. That's all. We did this problem in a very theoretical way. We did it in a theoretical way. I did it on purpose like that because you could actually plug in different points that they're showing you in the back of the book here. If you read the answers in the back of the book, they're telling you to try out different points and see what happens. And of course you could do that and see which points work and which point don't. Problem with that approach is that sometimes you get lucky and sometimes you have you don't get lucky, and you may have to try a few times or several times before, or you might try 1 or 2 times and might end up thinking that this thing works because you did not think of all the possibilities. This is very theoretical work, and the only problem in this entire scenario is this tiny small triangle right here, tiny small triangle from here to here to here. That small triangle is the bloody problem area, which is what I magnified there. My intention was actually to do one more problem today, but I'm not going to do that. I'm going to stop right now because I think this video is already way too long. I'll see you tomorrow, okay? Bye now.